Let's start off the chapter with Cartesian product of sets. We have come across the idea of Cartesian product as Cartesian plane. Cartesian plane is nothing but Cartesian product of sets of real numbers basically. What is Cartesian plane? That's nothing but your graph, right? So if you guys want to make a mental note, a Cartesian plane is nothing but a Cartesian product of real numbers. Cartesian product of real numbers. So what is this Cartesian product? So Cartesian plane, if you think about it, they are made up of something called as order pair. So what is this order pair? That is 1, 2. We find the coordinates, right? So similarly here too, we have, instead of real numbers, we can have between any two sets. That's the funda. That's it. As simple as that. So Cartesian product is nothing but given two empty sets like say P and Q. The Cartesian product between P and Q is the set of all the ordered pair of the elements of P and Q. For example, see, remember in Cartesian plane, what do you guys do? Say this is 1, this is 2 and 3 and all of that. So this is 1, 2 and 3 and all of this. What do you guys do? So this point is 1, 1. This point is 1, 2. This point is 3, 1. Sorry, this is 3, 1. This is 2, 1. This is 1, 1. This is 1, 2 and so on and so forth. Every point, including even the, how do you put it across? Decimal points, right? Even the minute point is related. So it's a relationship between real numbers. So real numbers includes all the possible numbers that you guys can think of. Of course, not the imaginary ones. Anyways, so basically we are trying to relate every element here to the every element over there. Okay. So the idea of Cartesian product is something that you guys are familiar with. So it's not something new. So every number is related to every number along the y-axis, right? And every element of the y-axis is related to every element of the x-axis. So now instead of real numbers, we have sets. That's it. Okay. So let me show the answer. So I have P and Q. I'm trying to find the Cartesian product between P and Q. That is P cross Q. See here the order matters. Okay. Because 1, 2 is not the same as 2, 1. So P cross Q is not the same as Q cross P. Remember that. So we are trying to do P cross Q. What is P made up of? A, B, C. And Q is made up of, starting from Ali to Divya. So now how do you write the order pair? So first take up your A and then you have Ali. And the last one in the first row would be this. Similarly, we take up B and then the name Ali and so on and so forth. So of course, I end up not writing all of that because that is a static work that can be displayed over here. So this is a program which contains set A, ABC, set B is Ali and all of that name. And the Cartesian product between them is nothing but set all of this basically. So every element you can see is related to every other element from the other set, right? You can see that. So this is a ordered list. Okay, so if I have say D also. So it'll just take a second. And we have the following output. If I remove one name from here, right? So you guys got the difference. Okay, so that's the basic funda. Every element is related to every element over there. That is your Cartesian product, as simple as that. So in roasted form, the output will look like this. Order pair, right? A comma the second name. Actually in sets the order does not matter, but within the order pair the order matters. Please know the difference, right? And the last would be C comma Divya. So this would be your set of ordered pair. So you can see over here, this would be your output basically. Okay. Now how do you represent this in set builder form? So P cross Q is nothing but made up of A comma B such that A will belong to set P and Q will belong to set, not Q, sorry, set B will belong to set Q. Again, it is the Cartesian product between P and Q is made up of the order pair A comma B such that A will belong to P and B will belong to Q. So how do you read this? Again, remember in sets we emphasized on learning the reading aspect as well, what the symbol represent and how do you read it, right? So here too we have this language, Cartesian product between P and Q is equal to set of all order pair such that P, in my case it is A and B, right? So I can change this to A and B, belongs to set P and Q belongs to set Q. So I just have to change this to P and Q. It would have been convenient if it was P, A and B actually. Okay, right guys. So it's a very simple concept, and yes, you need to understand that this is related to your Cartesian plane. It's a simple x and y axis plane that you guys have been using from 6th grade, I guess. Yeah.